Hi, today I am going to discuss about two transistor model of thyristor. In two transistor model, we will see the SCR 4 layers are represented by two transistors, PNP and NPN transistors. In last class, we have seen that a thyristor can be triggered by applying a small amount of gate current to break the junction J2. Four layers of thyristors we have seen P and PN. Today's class, these four layers will be split in two parts, PNP and NPN. PNP transistor, the current will enter into the emitter junction and come out from the base and collector junction. And in NPN transistor, current will come out from the emitter junction. You can see there are two diagrams, diagram A and diagram B. Both are equivalent to each other. In diagram A, the four layers P and P is splitted in two parts. The red boxes represents PNP and the green boxes represents NPN. Now come to the diagram B. Here in the diagram we can see these two boxes, green and red boxes, are separated, but still connection is there in between N and PP junction. You can see the anode, cathode and gate terminals are same as in figure A. Current will enter through anode junction and come out from cathode junction, and the gate current is there to break the junction J2 as we have seen in SCR. Now we will discuss how this gate current will trigger the SCR, or how anode to cathode current will flow by applying a small amount of gate current. Let's see the diagram. So in the diagram C, we can see two transistors are there, transistor number 1 and 2. One is PNP transistor, second is NPN transistor. In PNP transistor, current enters across the emitter junction, and in NPN transistor, current comes out from the emitter junction. For transistor number 1, anode current is the emitter current. For transistor number 2, cathode current is the emitter current. Now the base current of transistor number 1 is collector current of transistor number 2, and collector current of transistor number 1 is base current of transistor number 2. Now suppose gate current is not given across the system, then this collector current of transistor number 1 is equal to base current of transistor number 2 along with base current of transistor number 1 and collector current of transistor number 2 will form cathode current. That is a small amount of current, that is leakage current. Now we want to increase this anode to cathode current more than the latching current. To make that one, we have to apply a small amount of gate current. As soon as a gate current is applied, this gate current will be added up with collector current of transistor number 1 to form base current of transistor number 2. Now in case of transistor, we know that if a small amount of base current is applied across the transistor, then emitter current increases, or you can say collector current increases. So this effect we can see that by applying a small amount of gate current, IB2 increases, so IK will increase. In turn, IC2 will also increase. Now this IC2 is nothing but base current of transistor number 1, that will also increase. Now this base current of transistor number 1 increases, that will increase emitter current IA. So as a whole, we can say by applying a small amount of gate current, emitter current increases. Now this process continues. That means initially a small amount of base current will increase, then there will be a small amount of cathode current increase. This cathode current will increase a small amount of base current of transistor number 1, then a small amount of anode current will increase. Now as a small amount of anode current is increased, there will be a small amount of collector current of transistor number 1 increase. because current gain of the transistor alpha is equal to IC by IE. So if IA increases, obviously the current will increase and alpha will also increase. So as IC1 increases, then IB2 will further increase, increasing IK. So this process will continue till anode current reaches latching current. Then we can say the thyristor is completely on. So this is positive feedback effect. Regenerative action of these two transistors will make our thyristor on. Now let's discuss these things mathematically also. In this diagram, see same this figure, see we have discussed just now. Now let's verify this regenerative action mathematically. We know that collector current of transistor is related to the emitter current by equation IC is equal to alpha into I plus ICB0. ICB0 is collector to base leakage current, and this current is generally very low and we can neglect this one. In that case, alpha becomes IC by IE. So if IC and IE increases, alpha will also increase. So for transistor number 1, we can write the equation IC1 is equal to alpha 1 IA plus ICB01. For transistor number 2, IC2 is equal to alpha 2 IK plus ICB02. You can note that in place of IE, I have written IA for transistor number 1. Now come to this diagram, see here this emitter current is equal to anode current. That's why I have replaced that IE by IA. Similarly, in equation number 3, IK is replaced by IE. You can say IK is equivalent to emitter current of transistor number 2. Now, anode current is nothing but summation of these two currents, IC1 plus IC2. Applying nodal analysis or KCL, we can say IA is equal to anode current is equal to summation of collector current of transistor number 1 and collector current of transistor number 2. At the same time, cathode current is equal to gate current plus anode current. So from equation number 4, we can write anode current is equal to IC1 plus IC2 is equal to alpha 1 IA plus ICB01 plus alpha 2 IK plus ICB02. Simply substituting the values of IC1 and IC2 from equation number 2 and 3. Now replace the value of IK is equal to IA plus IG in equation number 4. We will get IA is equal to alpha 2 IG plus ICB02 plus ICB01 divided by 1 minus alpha 1 plus alpha 2. Now from this equation number 6, it is clear that if alpha 1 plus alpha 2 reaches close to 1, then denominator becomes very low and anode current will be very high. At the same time, if Ig is equal to 0, it is not possible to make alpha 1 and alpha 2 close to unity. So we can say from here that if a small amount of gate current is applied, then IB2 will increase, IC2 will increase, IA will increase. Ultimately, alpha 1 and alpha 2 will increase. So without applying gate current, it is not possible to trigger the SCR, or anyhow we have to break the junction J2. From equation 6, it is clear that by applying a small amount of gate current, we can increase the value of alpha 1 and alpha 2 and alpha 1 plus alpha 2. If it is close to unity, then an anode current is very high. Our purpose is to increase the anode current till latching current, because after latching current there is no need of this gate current. As we know that once the SCR is on, it will remain on till reverse voltage is applied across the SCR to make the thyristor off. So from equation 6, it is clear that a thyristor can be represented as equivalent to transistor model. So today we have discussed about two transistor model of thyristor, and we have seen that how a small amount of gate current triggers our SCR. So it is just the representation of SCR through two transistors. Thank you.